question number is 6. The question is, the spectra of a periodic signals are A. continuous, B. discrete, C. independent, D. none. That means we have to find out what is the Fourier transform of a periodic signal, and we have to identify whether that transformation is continuous or periodic, or it is independent of both. That means there is other factors which are dependent on this, and then none of the above. Let us see what is the answer. The answer is discrete. This is B. It is discrete. Okay, let us see why it is discrete. Okay, let us take a periodic signal which is Gp of t. This will have a Fourier transform which is 1 by t naught sigma n is equal to minus infinity plus infinity g of n by t naught delta of f minus n by t naught. Okay. Okay, as you see here, the Fourier transform is a summation which extends from minus infinity to plus infinity delta functions which are scaled by a factor g of n by t naught. So, as you see here, this is a scaling factor, and this is the delta functions which are existing at, let us say, n is equal to 0, 1, 2, 3, like that. Okay. So, this is a discrete function. Okay, the next question is 7th question. It talks about the spectra of non-periodic signals are continuous or discrete, independent or none. Let us see the answer. The answer is continuous. That means whenever we have a non-periodic signal, the spectrum will be continuous spectrum. So, the answer is A, that is continuous. Let us see the next question. In the frequency spectrum of non-periodic signal, the spacing among the components is A. large, B. small, C. 0. In the frequency spectrum of a non-periodic signal, the spacing among the components is large, B. small, C. 0. Okay. The earlier question we said that the frequency spectrum of a non-periodic signal is continuous. That means the spacing among the components will be 0. That is, the answer is C. Let us see the next question. The envelope of the frequency spectrum of a periodic pulse wave is given by the shape of the function. A. It is a sin x, B. sin x by x or sinc of x, then C. tau multiplied by a factor e, and D. x multiplied by a factor a. The envelope of the frequency spectrum of a periodic pulse wave is given by the shape of the function. A. It is sine, B. It is sinc function, C. It is e tau, D. It is ax. Okay. So, the answer is B. The answer is B, that is sinc x. So, this is the answer. So, if you take a periodic pulse, whenever I take a Fourier transform of periodic pulse, you will get a sinc function. Let us see the 10th question. The analysis of periodic waveform is generally performed in time domain A, frequency domain B, or C, which says that the analysis can be performed in both time and frequency domain. That means whenever you have a periodic waveform, how do you perform its analysis? Whether I perform the analysis in A, that is time domain, B, frequency domain, or C, time and frequency domain. Let us see the answer. The answer is frequency domain. So, whenever you want to perform the analysis of a periodic waveform, then we look at frequency domain analysis. So, the answer is B, that is frequency domain analysis. The next question is, a periodic pulse becomes a periodic signal if the time period approaches. A periodic pulse becomes a periodic signal if the time period approaches A. 0, B. infinity, C. 10 times its width, and D. none. Okay. So, the options are, if the time period approaches 0, A, if the time period approaches infinity, B, and C, it is 10 times its width, and D. none. Okay. The answer is infinity. So, periodic pulse becomes aperiodic if the time approaches infinity. So, the answer is B, that is infinity. Let us see the next question. The amplitude spectrum x of f is equal to a tau sin pi f tau by pi f tau holds for a continuous variable function of frequency, b a discrete variable, c both continuous variable function of frequency and discrete variable, and d none of the above. So, we have a function which is the frequency spectrum, which is given by x of f is equal to a tau sin pi f tau by pi f tau. We want to know what are the conditions under which this holds, and the answer is it holds only for a continuous variable function of frequency. So, it holds for a continuous variable function of frequency. So, the answer is A. So, question number 13 is as follows. When the phase angles of all components of a given signal are shifted by 90 degrees, then the resulting function in time is called A. Hilbert transformer, B. Ideal transformer. When the phase angles of all components of a given signal are shifted by 90 degrees, then the resulting function in time is called A. Hilbert transformer, B. Ideal transformer. The answer is A. Hilbert transformer, and we know that ideal transformer shifts the phase by 180 degrees. When the phase shift for all components is done by 90 degrees, it is Hilbert transformer. So, the answer is A. Let us see the next question. The next question is, the Fourier transform of a non-periodic signal function f of t is given by f of omega is equal to A. Integral minus infinity plus infinity f of t e to the power of minus j omega t dt, B. Integral minus infinity plus infinity f of t e to the power of j omega t, C. 1 by 2 pi integral minus infinity plus infinity f of t e to the power of minus j omega t dt, D. Minus infinity plus infinity f of t e to the power of j omega t d omega. Okay. This is the first formula which we have seen, where I have to calculate f omega given f of t. So, the answer is A, that is integral minus infinity plus infinity f of t e to the power of minus j omega t dt. So, let us write the answer is A. Now, question number 15 is as follows. If the Fourier transform of a function f of t is f of f, then the inverse Fourier transform is given by f of t is equal to A. Minus infinity plus infinity f of f e to the power of j omega t df, B. 1 by 2 pi integral minus infinity plus infinity f of f e to the power of j omega t df, C. 1 by 2 pi integral of minus infinity plus infinity f of f e to the power of minus j omega t df, and D. Integral of minus infinity plus infinity f of f e to the power of minus j omega t df. And the answer is A, that is integral minus infinity plus infinity f of f e to the power of j omega t df. So, the answer is A. The next question is question number 16. The frequency spectrum indicates A. The relative frequency of each of the frequency components, B. The relative phase of each of the frequency components, C. The relative magnitude of each of the frequency components, D. None of the above. The answer is the frequency spectrum is basically a spectrum which is shown with the help of the magnitude of the frequency component. So, the answer is the relative magnitude of each of the frequency components. So, that is question number 16. The answer is C. Question number 17. If the Fourier transform of a function f of t exists, it implies that A. Integral minus infinity plus infinity f of t dt exists, B. Minus infinity plus infinity mod f of t dt exists, C. Integral minus infinity plus infinity f of t dt is equal to 0, D. Integral minus t to plus t f of t dt exists. The answer is B, that is integral minus infinity plus infinity mod of f of t dt exists. So, Fourier transform exists only when this condition is satisfied. The answer is B. Let us see question number 18. If delta of t is the Dirac delta function, then A. Integral minus infinity plus infinity delta of d of f is 0. Integral minus infinity plus infinity delta of t df is infinity. C. Integral minus infinity plus infinity delta of f df is equal to 1, or D. None of the above. The answer is C, which says that minus infinity plus infinity delta of df is equal to 1. So, the answer is C. The next question, 19th. If the width tau of a single pulse of height a approaches infinity, then its Fourier transform is equal to. If the width tau of a single pulse of height a approaches infinity, then its Fourier transform is equal to A. Half of the amplitude given, that is a by 2, B 1, C a into delta f, D 0. The answer is C, that is a into delta f. So, the answer is C. Let us take a look at the next question, that is 20th question. If a function x of f is multiplied with the delta function delta of f and is integrated over the point where delta f occurs, then integral minus infinity to plus infinity delta of f x of f df is equal to how much? A. X of 0, B. X of f, C. 1, D. 0. The answer is A, that is x of 0. The answer is A. Let us look at the question number 21. The integral minus infinity to plus infinity delta of f minus f naught into x of f df is equal to how much? That means we have to find out what is the integral for a function x of f multiplied by f delta f function which is existing at f naught. What is the answer? A. X of f naught, B. X of f, C. X of 0 and D 0. The answer is A, that is x of f naught. Let us look at the next question, that is question number 22. For a function f1 of x dx to be classified as a Dirac delta function, it must satisfy the following conditions. So, what are the conditions? A. Integral minus infinity plus infinity f1 of x dx is equal to 1. B. Minus infinity plus infinity f1 of x minus capital X g of x dx is equal to g of capital X. C. Both A and B. D. None of the above. The answer is, for a function to be classified as a Dirac delta function, it must satisfy both the conditions. That is, the area under the curve must be 1, that is A, and B, which says the function exists at f1 x of x minus x, that is, it exists only at a point where f1 also exists. So, the answer is C. Next question, 23rd question. The spectrum of a DC signal is A. 2 pi delta of omega, B. 1, C. 0, D. 2 pi. The answer is A, that is, the spectrum of a DC signal is 2 pi delta of omega. The answer is A. We are able to answer all these questions based on what we have learnt about the Dirac delta function or a delta function. We have seen various properties of it. So, these questions are based on that. So, if you remember them, answering these questions will be very easy. Next question is, the Fourier transform of a function x of t is equal to e to the power of minus at u of t does not exist if a is greater than 0, b. a is equal to 0, c. a less than 0, and d. a is equal to 1. The answer is, we cannot have the value of a less than 0. So, the Fourier transform for this function, that is an exponential function e to the power of minus 8 u of t, exists only if c, that is a less than 0. So, the answer is C. Let us see next question, that is 25th question. The Fourier transform of x of t is equal to e to the power of minus at u of t is a 1 by a minus j omega, b 1 by a plus j omega, c a by a plus j omega, d a plus j omega. Remember earlier we have solved this type of problems using time scaling property. Okay, so what's the answer? The answer is B, that is 1 by a plus j omega. The answer is B. The next question, 26th question. The Fourier transform of a unit impulse function delta of t is a 1, b 0, c delta of omega, d pi. The answer is A, that is the Fourier transform of a unit impulse function is 1. So the answer is A. Okay, that means you have a delta function here. If I take its Fourier transform, I will get an answer like this. This is the frequency domain. So the answer is A, which is a 1. Let us look at question number 27. The Fourier transform of a unit step function u of t is A 1 by j omega, b pi into delta of omega, c 1 by j omega plus pi into delta of omega, d 0. The answer is 1 by j omega plus pi of delta of omega. Okay, this we have solved in our earlier solutions of some of the basic formulae we have done, where we have proved that this is in fact equal to. So the answer is 1 by j omega plus pi delta of omega, answer C. Let us look at question number 28. The inverse Fourier transform of a signal delta of omega minus omega naught is A 1 by 2 pi, b 1 by 2 pi e to the power of j omega naught t, c 1 by 2 pi e to the power of minus j omega naught t, d e to the power of j omega naught t. The answer is B, okay, where we have made use of the frequency scaling property of Fourier transforms. So the answer is B, that is 1 by 2 pi e to the power of j omega naught t. So the answer is B. The next question, that is 29th question. Fourier transform of a signal x of minus t is A minus x of omega, b minus x of minus omega, c x of minus omega, d x of omega. The answer is C, that is the Fourier transform x of minus t in fact will be x of minus omega. So the answer is C. Let us look at the next question. The Fourier transform of f of t is equal to mod t is A minus 2 by omega square, b 1 by omega square, c 2 by omega square, d minus 1 by omega square. The answer is minus 2 by omega square.